The overall objective of the drone is to take off and begin searching. Detect the flower, lower, and pollinate it. It should then return to search altitude, and eventually resume search pattern. It cycles through these states until the system is fit to land.
We initially intended to develop a small modular drone. The goal of the small form factor was to minimize the propeller downwash and increase maneuverability. However, limitations in the form of battery life, unreliable motors, and a lack of space for additional sensors eventually led us to purchase a larger drone body. This drone allowed us to evaluate our experimental setup. Search patterns were created with positional waypoint generation. Our team created functions which generate spiral search patterns with variable parameters such as search radius and spiral density. We produced discrete set points at a fixed frequency, allowing the drone to search at a stable target speed.
For the next objective, flower stabilization, the system must be capable of leaving the search pattern whenever a flower is detected. Our team used an open-NV camera to perform vision detection. Because some flowers typically have a brown or black center, we detected a flower by identifying a non-yellow color blob contained within the distinct yellow color. This flower detection is used to control the drone mid-flight. Once a flower is identified, the drone will break away from its search pattern and begin to stabilize over the flower. Once the drone has centered over the flower, it will begin to descend.
The drone runs ROS Noetic on a Raspberry Pi. We use the MavROS library to convert positional and velocity commands from ROS to MavLink in order to communicate with the Pixhawk flight controller. Commands that interface with the Pixhawk directly are handled by lower-level nodes, while waypoint navigation, flower stabilization, and drone descent are all implemented in a high-level state machine.
In this demonstration, you can see the drone spiraling around the field. Once it detects the flower, it then centers over it. When the drone is confident about its location, it then descends to the flower's height. After pollination is completed, the drone then ascends to its search altitude and continues the search pattern. Here, it detects the second flower and repeats the pollination process.